Okay friends, so this is how the block diagram for a closed loop control system will look like. The main difference in case of this open loop and closed loop control system is nothing but what? The existence of this feedback signal, right? Open loop system has nothing to do with that feedback signal. In case of that closed loop control system, always there will be an involvement of this feedback signal, means some part of that output is being feedback towards the input. So obviously the feedback signals are proportional to the output signal, right? So this is how the entire structure of this closed loop control system will look like. When we start our journey with this first block, that is nothing but a transducer. So initially this transducer is excited with the help of that input pulse or the input command, okay, to generate the reference input signal denoted by this R of t. And what this symbol stands for, that can be called as a signal multiplier. A multiple number of signals can be added or subtracted with the help of this multiplier, what we can say that, right? After that multiplier, these two blocks are nothing but what? This is how the open loop control system will look like, which consists of controller and processing unit. The processing unit is responsible to generate the control action out of it, means the desired quantity which is responsible to turn on that system to attain a certain objective out of it, right? Here we used to have the feedback element, right? So this controller is activated by this error signal E of t, right? Now how to get this E of t? By subtracting or by adding these two signals, right? Which two signals? This R of t plus minus of B of t. B of t is nothing but what? The desired feedback signal which are to be obtained from this output denoted by this C of t basically, right? Time domain representation. The signals which are proportional to the output of that system. So in this way this error signal is generated to operate the controller, right? And the controller output is being given to this processing unit. For sake of our convenience, if suppose it is being denoted by U of t, right, which is given to this processing unit to generate the control action out of it, right? Then once the control action is to be generated by this processing unit, then what will happen? Some part of that output is being feedback towards the input during each and every signaling interval, what we can say that. So this is how the closed loop control system will look like, right? Now the question arises just similar to the open loop control system. What will be the best example for this closed loop control system? So the refrigeration, the air conditioning unit or any automatic electric iron, that can be falls under the category of this closed loop control system. Let us try to map this closed loop control system with the help of this electric iron example or automatic electric iron, right? Our objective is to iron our clothes, right? So electric iron will try to regulate its temperature according to the cloth selection, whether it is silk, cotton, polyester, whatever it may be, right? So the within that electric iron we used to have the thermostat, right? So when we replace this transducer with that thermostat, right? So what kind of input is being given to that electric iron here? The input will be what? The desired temperature which we want to iron what kind of cloth which we are interested, either it is cotton, polyester, silk, whatever it may be, right? So here we used to have that thermostat portion here, or it is one type of valve which will operate it as a on and as a off. It will try to monitor the temperature of that iron according to that cloth. Then after that we used to have this controller and processing unit. So if we replace this controller with this switch, and the processing unit is nothing but what? The heater, which is the main heating element into that electric iron or the heating coil. And these are nothing but what? The feedback signal. Instead of that rectangular box, if such type of feedback signals are being taken into account, right? So why this iron falls under the category of this closed loop control system? Because each time some part of this output is being feedback towards the input. Here the corresponding element is nothing but what? Thermostat will try to map the current temperature of that iron, which is based upon which cloth, what kind of cloth we are interested to iron, right? Once the desired temperature is being maintained, or once the desired temperature is being given, Then after that, the role of this thermostat is to monitor the temperature of this heating coil. If the temperature of that coil decreases from that threshold value, then what will happen? This switch will be turned on and it will try to maintain the desired temperature by turning on that heater. If the temperature reaches to the desired potential level, obviously this switch will turn off that heater, right? So each time some sort of feedback is being given into that system, right? So this is this is all about the introductory part of this control system, right? This control system, broadly it is being classified into open loop and closed loop control system. We need to remember that in case of open loop system, we don't have any kind of feedback signal. The control action has nothing to do with the response of that system. But in case of closed loop control system, the control action depends upon the response of that system. Means we do have the occurrence of that feedback signal in case of this closed loop control system, right? So this is all about this open loop and closed loop control system. Thank you.